So this lecture, we're going to look at two special angles, the angle of elevation and the angle of depression. They come up a lot in practical applications. So to define these, we're going to start with an observer and 2 points, one above him and one below him. Now, if we draw a line horizontal through the observer's eye level and another line up to the object that's up above the line of sight, then the angle between that line and the horizontal is what we call the angle of elevation. Similarly, if we draw another line from the observer down to the point below, the angle between that line and the horizontal is what we call the angle of depression. All right, so let's take a look at an example, right? See how we can make use of these two ideas. So you have a situation here. We have an airplane and we know its altitude, and it spots a light on a runway, and I know what the angle of depression down to it is. So I want to use this information, see if we can find the ground distance between the two. All right, so anytime I have a practical situation, I like to start by making a drawing. So I'll start by drawing the ground. Then up here we have an airplane. And over here we have that light source that it's tracking. And I know the plane's height. The plane is 32,000 feet above the ground. All right, now with this angle of depression, you always have to be a little careful, right? Because there's a temptation to draw this line in here, because you can see that's going to make a right triangle. We like it when right triangles show up in problems because we know all sorts of properties for them. And at this point, it's tempting to make this angle here 18.1 degrees, but it's not. Where the angle of depression is the angle from the horizontal down to the line out to the object. So it's this angle that's going to be 18.1 degrees. I know that's great, but to apply any kind of trig ratios here, first I need to know that it's a right triangle, and it is because that we drew this straight down to the ground. And I need to know some more angles in this triangle. Right? Well, the easiest way I think to get at this is to say, look, that horizontal line that I drew out from the plane and the ground, they're parallel, which means this 18.1 degree angle and this angle down here are alternate interior angles to those parallel lines, which means they have to be congruent, which means this angle is also 18.1 degrees. And that should be all I need. But the one more thing I want to be clear about what we're being asked for. We're asked for the ground distance. Right, that's going to be the distance here from the point the plane is over out to the runway. Right, so if we call this x, then we can get some trigonometry in here. The tangent of 18.1 degrees is equal to 32,000 divided by x. Remember, the tangent is the opposite over the adjacent, opposite side over the adjacent side. Right, then if we go to solve this, this is x times the tangent of 18.1 degrees equals 32,000. Let's multiply both sides by x, right, to get it out of the denominator there. Then we'll divide both sides by the tangent of 8.1. We get x is 32,000 divided by the tangent of 18.1. And at this point, you have to go to your calculator, right? You ask your calculator what this is, and you're going to end up with 97,904 feet, right? And it's got to be feet because that's what the altitude value was in. Right, and that's fine. I mean, it's not a bad answer. And that is how the heights of planes are usually given, right? In a number of feet, even if the number is fairly large, like 32,000. As a practical matter, we probably don't want the answer in feet, although the question didn't specify. So this is like a test question or something, I would absolutely accept that as an answer. But if we wanted to get this into a slightly more realistic unit, we can use the unit conversion, the dimensional analysis process that we talked about in the measurement lectures, and multiply this by 1 mile divided by 5,280 feet. And if we do that, this comes out to 18.54 miles, or just about 18 and a half miles. And that really is kind of a more realistic unit to use to give this answer. So this brings us to the end of our discussion of trigonometry. In the next section, we're going to switch gears and talk about something called tiling. And I really like this section. It's a relatively modern branch of math, and there are a lot of drawings, a lot of very artistic drawings, right? So I think the subject has appeal to a lot of people, even those who maybe aren't necessarily super excited about the math part.